Alright, so we're in lesson 2.12, which is more solving quadratic equations using the quadratic formula. This is our last lesson for Unit 2, so let's go ahead and get started. So first of all, we're going to start this out with this warm up out with a word problem, and it says an object is moving in, let's highlight some stuff here maybe. And so it says an object is moving in a straight line. It initially travels at a speed of 9 meters per second, and it speeds up at a constant rate of 2 meters per second each second. Under such conditions, the distance, let me highlight that, the distance in meters, so the distance is measured in meters, that the object travels is given by the equation. So we can see that this equation right here, and it says where t, again, t is the time that's recorded in seconds. According to this equation, how long will it take the object to travel 22 meters? So they're looking for when the distance is equal to 22. And so here we can see that the distance in this equation, the distance is equal to the time squared plus 9 times the time again. And so they want us to find out how long, let's highlight this, how long it will take an object to travel 22 meters. So we know that we have to substitute 22 in for d, and so we have t squared plus 9t. So here I have to solve this equation for t. So that means to solve an equation, it means to get t by itself. So how am I going to do that? I'm going to use what we've been talking about, and that's the quadratic formula. So I'm going to say the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4a times c, and all of this is divided by 2a. Please be careful how you write your stuff here, and make sure you write it exactly how it's supposed to be written so you won't confuse yourself. I see you guys do that a lot. Alright, so we're going to first identify the a, b, and c. But first, before I can do that, I have to make sure that I have 0 over here. So in order to get 0, that means I have to subtract 22 from both sides of this equation. So this cancels out, and so now I have 0 is equal to t squared plus 9t minus 22. So I got rid of the 22 on this side of the equal sign, and now it's over here. So since this is now equal to 0, since I made it equal to 0, by subtracting the 22, I now can identify what my a value, my b value, and c value is. So a is always connected to the term that has the exponent of 2 on it. B is always connected to the term that has the exponent of 1 on it, and C is always your constant term that doesn't have anything on it. Now we want the value, so A is not t squared, A is 1, because that's the coefficient that's in front of that term. And so B quite naturally would be 9, and C would be negative 22. So I come over here and I substitute these values into the quadratic formula, and so I get x is equal to negative 9, because there's a negative in the equation, plus or minus the square root of b. I'm going to put this in parentheses. Every time I substitute something in, let's put it in parentheses, and I probably should have put this in parentheses too. So I'm going to go back and fix that. Minus 4 is already in the equation. Have to substitute 1 in for a, and I have to substitute negative 22 in for c. So all of that is under that square root, and then this is divided by 2 times substitute 1 in for a. Okay, now first, this is all x equals, okay, and in this case it should be t equals, because in this case this represents t, okay, because that's the variable that we solving for. So this actually could be t equals instead of x equals. So let's change that, because that's the variable that we're working with. So we're going to change that to t so it makes sense for this equation. So it's t equals, okay. Alright, so now I'm going to clean this up a little bit. So I'm going to simplify. First, I'm going to work on simplifying, and let me write t equals again. So simplify the first part here, and so I should get just -9, okay, plus or minus the square root. Now to simplify what's under the square root, I'm just going to pull up my calculator. And so when I pull my calculator up, I'm just going to plug just the stuff under the square root. Notice I'm not going to hit the square root. Please don't hit the square root. Okay, we're just calculating the stuff that's under the square root. So open parentheses, close parentheses, 9 squared minus 4 times open parentheses 1, close parentheses, open parentheses, -22, and then close parentheses. And so I get 169. So 169 goes underneath the square root, and this is all divided by just 2 times 1, which is 2. Okay, so we simplified it to that point. So now I'm going to look and see, well, can I simplify my radical? Quite naturally, you guys should see that 169 is a perfect square, but if you don't see that, you can go and fix that. So 69 is a perfect square, so the square root of 69 would just simplify to just 13. So t is equal to -9 plus or minus. So instead of writing the square root of 169, I'm now going to write 13, because the square root of 169 is 13, and this is still divided by 2. Okay, and so now what I want you to see here is you have two solutions. This is what this plus and minus is for. Again, so my first solution is t is equal to -9 plus 13 divided by 2. And my other solution is t is equal to -9 minus 13 divided by 2. Okay, so when you calculate that, you can put that in your calculator. -9 plus 13 divided by 2. That's going to give me 2 here. And then I do -9 minus 13 divided by 2. And I should get -11 here. So you see I have two solutions, but quite naturally, if I'm answering the question above, this is not going to be a solution because time cannot be negative, so therefore it is just 2 seconds. Okay, so let's look at some more examples here. So first of all, using the quadratic formula, and if you have to write the quadratic formula down every single time, that's fine. X equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, and so I'm going to come over here. I see that this is f of x is equal to x squared plus 4x plus 5, and I want to solve these equations using the quadratic formula, of course. So that means to solve, it means I'm finding the value of x. So if I'm finding the value of x, that means f of x has to be 0. So there is no number that I have to substitute here. So I'm just going to make f of x 0. Okay, so 0 is equal to now x squared plus 4x plus 5. So now I can determine my a, b, and c value. So this is a, this is b, and this is c. So now I substitute those into the quadratic formula. So x is equal to, b is 4, right? B is 4. So it's minus, open parentheses, 4. Every time I substitute something in, I want to put it in parentheses. All right, and open parentheses, and another 4 is going in for b, but I'm going to square it this time, minus 4 times A is 1, okay, and C is 5, okay, and this is all divided by 2 times 1 again because A is 1. And if you have to write those values there, you can. So A is 1, B is 4, and C is 5. So now I simplify everything, so I get X is equal to negative 4 plus or minus the square root of some number that's going to go under there, and it is divided by just 2. Okay, so now I'm trying to find out what goes under my square root, so I'm going to put this in my calculator. So 4 squared minus 4 open parentheses 1 5, okay, and so I get negative 4, so negative 4 goes under here. Automatically I know that this right here is going to be an imaginary solution because I see that there is a negative under my square root, but no problem because I know how to simplify negative square roots. And so when I simplify that negative square root, I should get X is equal to negative 4 plus or minus 2i divided by 2. Now I could go a little bit further by dividing the 2 into both of these, okay, because it's almost like a fraction. So I'm going to circle that in different colors. So when 2 go into, let's pay attention to this. Okay, so 2 goes into negative 4, so negative 4 divided by 2, I get negative 2. So let's move this up. Alright, so this is going to give me just negative 2. So X is equal to negative 2 plus or minus, and then 2 divided by 2, 2 divided by 2 is just going to give you 1. So that's going to just be 1i, but I just can write I. So these are my solutions, and I have 2 solutions. So one of my solutions is negative 2 plus I, and my other solution is negative 2 minus I. Okay. All right. Let's look at another example here, and let me just show you something really quick. If I can scroll up, let's see. How can I scroll up? All right. So I think I want to show you guys something really quick before I just kind of move on. So I want to show you what this equation will look like inside of Desmos. So I'm going to say f of x is equal to x squared plus 4x plus 5. Okay, and if you notice here, when I graph this equation right here, it doesn't cross the x-axis at all. So you would probably say it doesn't have any x-intercepts. So when you encounter a situation like this, you do have x-intercepts. The x-intercepts are just imaginary x-intercepts like these. These are imaginary numbers. You just won't have real x-intercepts. All right, so hopefully that made sense there. All right, let's move on. So let's look at another example here. Still using a quadratic formula. So again, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And again, we're solving this for x, so this has to equal 0, which, you know, we don't know what it is. So we're just going to set it equal to 0. So it's 3x squared minus 2x plus 2. Now we see that our a is 3, our b is negative 2, and our c is positive 2. Okay, so we substitute our values in. So x is equal to negative, open parentheses, b is negative 2, plus or minus b squared, so negative 2 squared minus 4 times 3, open parentheses, 2, okay? and then this is all divided by 2 times 3 over here. So now we want to simplify that a little bit. So x is equal to, now you got a negative times a negative, so that's going to make a positive. So that's going to be a positive 2 plus or minus the square root of, put all this stuff in your calculator. So open parentheses, negative 2 to the second power minus 4, open parentheses 3, and then 2, and then so I get negative 20. So negative 20 goes onto here. So automatically I know that this is also going to be an imaginary number as well. And so under the bottom I get 6. Now my next thing is to try to simplify this square root. And so when I simplify the square root, I get x is equal to 2 plus or minus, that breaks down into 4 and 5. 2 is a perfect square. The I comes out. So this should be 2i square roots of 5. And then this is divided by 6. Okay, so again, I can go a little bit more because I'm going to treat these like they're fractions, okay? And I'm going to try to basically simplify them, okay? So I'm going to start with the blue one, and these are whole numbers. So first thing, I'm going to start with the 2 and the 6. So I'm going to say, well, let's see if I can simplify 2 divided by 6. I get this decimal number, but I know how to change that into a fraction now. So I get 1/3, okay? So, and then quite naturally, 2 divided by 6 again is going to give me the same thing. Okay, 2 divided by 6 again is going to give me the same thing. I change it into a fraction, which is 1/3. So therefore, x is equal to, this is should be 1. So this is 1. Remember, because it was 1/3 plus or minus 1 again, but it's 1 times I, and then times the square root of 5. And this time, instead of it being over 6, it's going to be over 3, because that's where the 1/3 for both of those numbers. Remember, 1/3 and 1/3 came here. So this would be my solution, which is x equals 1 plus I times the square root of 5 divided by 3. That's one solution. And then my other solution is 1 minus I times the square root of 5 divided by 3. So those are your two solutions. Okay, let's look at another example here. Hopefully you guys are getting it. So this one says, it says p of x is equal to 2x squared minus 7x. And it wants me, it says when p of x is equal to negative 12. So it's telling me the value of p of x. So obviously I have to substitute negative 12 for p of x. So I'm going to put negative 12 for p of x, and this is still going to equal 2x squared minus 7x. So this time I have to make this equal to 0. So in order to make this equal to 0, I'm going to this time add 12 to both sides of my equal sign to get rid of the 12, because I want 0 over here. So now I have 0 is equal to 2x squared minus 7x plus 12, because you can't combine any of these because they're not like terms, so you just tag it on like a chain. Okay, so now I have my setup to where this is my A term, this is my B term, and this is my C term. So my A is equal to 2, my B is equal to negative 7, and my C is equal to positive 12. So use the quadratic formula to solve for x. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2a. Please be careful how you write this so you won't mess yourself up. Okay, so x is equal to, we're substituting in, so we're going to use parentheses. So negative 7 is being substituted for b times the square root of negative 7 is going in again, don't forget the squared, minus 4 times 2 times 12, okay? And this is all divided by 2 times 2 in this case because a is 2. So now I simplify this, so I get x is equal to, I got a negative and a negative, so that's going to make a positive. So a positive 7 plus or minus the square root of some number is going to go under there when I simplify it, and then 4 is going to go at the bottom. Alright, so now I'm taking this stuff inside. I'm going to plug it in my calculator. Negative 7 squared minus 4, 2, and then 12 under there. So I get negative 47. So I know that this is going to be an imaginary number because of the 47 is negative. And so now I go and let me get another color. I'm going to rewrite this because I'm going to try to simplify the square root of 47. But the only thing I can pull out of that, because it doesn't really factor, okay, 47 is a prime number. So you can try it, you know, you can go to y equals and you can put 47 divided by x, and then you can see if you can find factors. But you know, other than 1 and 47, that's it. Everything else is going to be decimal numbers. Okay, so therefore 47 is, you can't do nothing with it, so you have to leave it under. So the only thing you can bring outside is an I. So it'll be I times the square root of 47 divided by 4. And so this time, since 4 can't go into 7 and this evenly, okay, and 7 over 4 can't even be simplified, you can plug it into your calculator. 7 divided by 4, look, you get 1.75. But when I turn that back into a fraction, it just gives me 7 over 4. So this is as far as I can go. So this would be my solution, or my two solutions. So x is equal to 7 plus I times the square root of 47 divided by 4. And x is equal to 7 minus I times the square root of 47 divided by 4. And that's basically my solutions. So I know if I graph this equation right here, I know it would show me a graph that wouldn't cross the x-axis at all because my solutions are imaginary, right? So if I go back here and I look at these solutions, they're imaginary, so this graph would not cross the x-axis either. If I look at here, these solutions are imaginary, so it wouldn't cross the x-axis. Remember here, these solutions are real solutions, so this would cross the x-axis if I were to graph that. So I will get real solutions in that case. So understand, you can check and see when you're going to have real solutions and when you're not. Alright, so let's look at one more example here. So still using the quadratic formula. So we got quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so here, this is basically done for us. We're solving for x, so therefore we have to set y to 0. So I'm just going to make y equals 0. We have x squared minus 6x plus 9. So where is this is my a value, b value, and c value. So, and that is a 9, not an a. Let me make that look like a 9. Okay, so over here I know that my a is 1 because the coefficient is 1. My b is negative 6, and my c is positive 9. So I know my value. So now I'm going to come over here and plug it in. So x is equal to negative. Everywhere I substitute these values in, I'm going to put parentheses to help me to distinguish what I'm substituting in. Okay, so I put negative 6 squared minus 4 times 1 times 9, and that's a 9 there. It's not an a, that's a 9. And it's all divided by 2 times 1. Okay, so this is going to be x is equal to a negative, and a negative is going to make a positive, so I know that this is going to be a positive 6 plus or minus the square root of some number is going to go under there, and this is divided by 2 because 2 times 1. So now I need to find out what goes under the square root. Open parentheses, negative 6, I square it, minus 4, 1, and then a 9 goes under there, and then I hit enter. So I get 0. So guess what? 0 goes under the square root. So now what do I have here? So now you basically have just one solution. So, because if you take the square root of 0, it's just 0. It's nothing there. So x is equal to 6 over 2. The plus or minus goes away because the square root of 0 is there and it just makes 0. So therefore you don't get 6 over 2 plus or minus, because it's plus or minus nothing, because this makes 0. If you do the square root of 0, it's just 0. So this is nothing over here. Okay, so understand that. So therefore we have one solution here. So we have x is equal to, well, I can divide this. 6 divided by 2 is just 3. So my solution is 3. If I wanted to check this, I could, oops, sorry. My first mistake this time. So I could go to Desmos and I can plug that equation in. So I got y equals x to the second power minus 6x plus 9. And so I graph that, and I can see right here is the point where it crosses the x-axis. Okay, so this is our solution. So in a nutshell, you sometimes can go to Desmos, graph your equation, and if you find out where it crosses the x-axis, if you haven't put that together, those are basically your solutions. The only problem is, well, what happens when I have complex solutions? Remember that when you have complex solutions, the graph is not going to cross the x-axis. Let me show you here. So if you go here and plug it in, so you get, let's put g of x equals 3x squared minus 2x plus 2. So if I go here, you notice that this green graph doesn't cross the x-axis at all, and so when that happens, you're going to get imaginary solutions, so you can't tell. So you have to use the quadratic formula to kind of help you to find what those solutions are. Okay, so here is a use try problem. It is a word problem. Please read the word problem carefully and then try to solve it and find your solution to the word problem. And using a quadratic formula is a little hint to help you out. And we'll come back and try this all tomorrow.